Dear students, we'll discuss about reciprocating pump. Pumps are defined as hydraulic machines which convert hydraulic energy into mechanical energy. So these are the main parts of reciprocating pump, that is piston, cylinder, suction pipe, delivery pipe, suction valve and delivery valve. Okay, here HS is called as the suction head and HD is called as the delivery head. Okay, then the other parts are the connecting rod and the crank. Right, now we will find out how much is the discharge, work done and power given by the single acting reciprocating pump. So the discharge of the pump per second is equal to discharge in one revolution multiplied by number of revolutions per second, and this is equal to ALN upon 60. Then the weight of water delivered per second. So weight of water we have multiplied by the specific weight, and therefore capital W is equal to rho G into Q, that is rho G ALN divided by 16. So how much is the work done per second? So the work done per second is nothing but the weight of water lifted multiplied by the total height through which the water is lifted. So the total height through which the water is lifted is nothing but HS plus HD multiplied by W, and therefore the power required to drive the pump is work done per second. So if you put the work done, you will find the power, and this is equal to rho GALN into HS plus HD divided by 60 into 1000, that is 60,000. Right. So work done per second and power. Similarly, we'll find out the discharge, work done and power required to drive a double acting reciprocating pump. So here is the arrangement for the double acting reciprocating pump. Suction and compression from both sides. Okay, so here as the suction and compressions are from both sides, so how much is the total area? The total area is nothing but pi by 4 capital D square minus pi by 4 small d square. Right, so this is the area on other side of the piston. Right, and we already know the area of the piston, that is pi by 4 d square. Okay, so the volume of water delivered in one revolution is nothing but the area on one side of the piston multiplied by length of stroke into the area on the other side of the piston multiplied by the length of stroke. So here length of stroke is common, and this is the equation. Now the discharge. Right, so this discharge of pump per second is volume of water delivered in one revolution multiplied by the number of revolutions per second. Right, so if you put the value, this is pi by 4 capital D square plus pi by 4 into capital D square minus small d square multiplied by L into N into 60. Right, so if you solve this equation, the discharge is 2ALN divided by 60. Similarly the work done. Right, so work done is nothing but the weight of water delivered multiplied by the total height. Right, so here the weight of water delivered multiplied by the total height is rho G into 2ALN upon 60 into HS plus SD. Similarly, power required to drive the double acting reciprocating pump. Right, so here we need to multiply by 2 only.